Hello and welcome to the CPD on weathering steel bridges. My name is Chris Dolling and I'm the Manager of Technical Development at the British Constructional Steelwork Association. Over the next hour I'm going to take you through what the material is and how it works. I'll talk about the benefits of weathering steel and also the limitations, and I'll comment briefly on availability and appearance. Before moving on to the bulk of the presentation, which will be design considerations, detailing considerations, fabrication and installation, and inspection and maintenance. And I'll close with a few comments on possible remedial measures should corrosion rates exceed those anticipated at the design stage. So, what is weathering steel? Well, it's a high-strength, low-alloy structural steel developed in America by United States Steel in the 30s. And it wasn't developed for structural purposes, it was actually developed to resist corrosion and abrasion in their iron ore wagons. And it was given the name Corten. Now, it was first used in a structure on the John Deere building in Illinois, and that was in '64. It was first used in the UK at York on a footbridge in 1967. It is now widely available in Europe, and it's called structural steel with improved atmospheric corrosion resistance. Not quite so snappy as Corten, but there you go. It's a non-proprietary product and it's specified to a European material standard, which is EN 10025 Part 5. There are 3 grades suitable for bridge works, and I've listed them there. There's another grade that's mentioned in the standard called S235, but this is rarely made, if ever, so you really should not be specifying 235 weathering steel. Another point to note is that the material standard does not cover the equivalent of an NL toughness subgrade, so that could be an issue if you have thick plates over approximately 70 millimeters. The material can be produced with equivalent toughness, but it would just be non-standard. Now, the key thing with weathering steel is you don't have to paint it. How can that be? Surely it will rust. Well, yes, it will rust. All low-alloy structural steels have a tendency to rust in the presence of oxygen, moisture, and contaminants. What happens is the oxygen and moisture attack the steel surface and oxidize the iron to form iron oxide. Now, this is rust, and the rust forms a layer on the steel surface, and that slows down the access of oxygen and moisture to the steel below it. Now, with ordinary structural steel, after a while the rust falls off, exposing fresh steel to the corrosion process. So for ordinary structural steels, corrosion progresses as a series of incremental curves, approximating to a straight line. The slope of this straight line is the average corrosion rate. With weathering steel, corrosion starts in exactly the same way. But the key difference is the alloy content in the material changes the behaviour of the rust layer, making it much less porous and much more adherent to the base metal. So put simply, the rust sticks. So under conditions of alternating wetting and drying, this stable rust layer develops that protects the material. It doesn't stop the corrosion process, it just slows it right down to an acceptably low level. So what are the benefits for the clients, the bridge owners? Well, the key one is low maintenance. Because you're not painting it, you don't have to repaint it in 30 or 40 years' time. Consequently, it's ideal where access for future maintenance is difficult or dangerous. A typical example would be over a major railway. This one here is the East Coast Main Line at Doncaster. We have a very nice weathering steel bridge there. Another benefit is economics. Weathering steel is slightly more expensive than ordinary structural steel. However, that extra cost is more than offset by savings from eliminating the paint system. Now, there was a study done in the late 90s by ECCS, which is the European Convention for Constructional Steelwork. And they looked at 8 bridges, costed the 2 alternatives, and found that weathering steel was approximately 5% cheaper on initial capital cost. Not much, I hear you say. However, once you look at whole life costings, then weathering steel really does become a clear winner, because the direct costs of the future maintenance are avoided, and also the indirect costs, such as traffic delays or railway possessions. Another benefit is speed of construction. Because you're eliminating factory and site painting, it's quicker to build with weathering steel. It also has an attractive appearance. It gives a very nice dark brown colour that blends in well with rural environments and actually improves with age, so it's quite a rare material. This example is Hayden Bridge Bypass, and there's a couple of fly fishermen there in the River Tyne South. What a lovely setting. There's also a benefit for the environment in that because you're not having to paint it, you don't have to worry about solvents from the paints. Also, because you're not having to repaint it, you don't have to worry about disposing of the blast cleaning debris. So there's an environmental tick in the weathering steel case. There's also a tick for health and safety if you use weathering steel. Because you don't have to paint it, you're not putting workers at risk from the painting operation. And because you don't have to repaint it in the future, there's benefits in terms of future maintenance. This is particularly important for box girders, because the inside of the box girder is a confined space. So using weathering steel minimises the risks, which is important in terms of CDM. This example here is the River Usk crossing in Newport. It's painted on the outside because the architect wanted a white colour, and also because it's a marine environment, which I'll come on to later. But the inside of the box is unpainted, so the weathering steel is providing health and safety benefits.